Hello! In this video we're going to talk about the idea of slope fields. So let's start with an example. Differential equation dy dx is equal to 1 minus 1/2 times y. So a slope field is a way of looking at solutions to this differential equation without actually solving the differential equation. And we're going to take advantage of the fact that dy dx is the slope of solutions on a graph. So for example, the slope field for this differential equation would look something like this. Now don't worry, we're going to talk a little bit about how to draw this slope field in just a minute, but first I want to show you what it looks like and why we're going to use it and how we're going to use it. So this slope field tells us a lot about the behavior of solutions. In particular, if you choose a particular solution, namely an initial condition, say y at x equal to 0 is 5, then you can figure out what happens to the behavior of this solution without solving the differential equation. So we just start at that initial condition and then follow the solution by following the slope, and it tells us that the long-term behavior of the solution looks something like this. And we can do that without ever having to solve the differential equation. Alternatively, I can look at other particular solutions at the same time. So let me consider y at x equal to 0 is 0. So I start here, and I can follow the slope field to tell me what the behavior of this solution is as well. So the advantages are quite clear. You can understand a lot about solutions to differential equations without actually having to solve the differential equation. And this is useful because sometimes you can't solve a differential equation exactly, but you still want to know what solutions behave like or how they work. And a slope field is an ideal way to understand that. So how do you sketch a slope field? Well, what we're going to do is we're going to use this differential equation, and we're first going to see if there are any equilibrium points. Equilibrium points are locations where dy dx is equal to 0. And indeed, if we set dy dx equal to 0, this happens when y is equal to 2. And so we can see everywhere when y is equal to 2, the slope will be 0. So in the graph, we place at the line y equal to 2 horizontal lines showing that the slope is 0 along that line. Now we want to understand what the slope field looks like for the rest of this graph. So then let's consider points slightly above or below the equilibrium point. And then dy dx is the slope. So let's look slightly above the equilibrium point for y greater than 2. So as y is a little bit greater than 2, dy dx, which is 1 minus 1/2 y, is actually negative now, since y is larger than 2. So the slope is negative. So what I'll do is I'll draw in little negative slopes on equal intervals on my graph. If I'm slightly below the equilibrium point, if I'm at the point y less than 2, then the slope dy dx is going to be positive. And so I'm going to draw at equally spaced points small positive slopes to show me what the slope is looking like there. Of course, I can go further above the equilibrium point and further below the equilibrium point to fill out the rest of this graph. And as I go higher up above y equal to 2, my slope becomes more and more negative. And as I go more below y equal to 2, my slope becomes more and more positive. And so I've taken into account the changes in slopes as well as the sign. I can see from this that I have a special solution. There's something special about the equilibrium point, which is that it's a stable equilibrium. So a stable equilibrium point is an equilibrium point where the solutions tend towards it. And so we can see here that solutions tend toward the equilibrium point, so we're going to call it stable. An unstable equilibrium would be the opposite. Solutions tend to move away from the equilibrium if they're off of that equilibrium point. Okay, I hope this gives you some idea on how to draw slope fields and why they're useful.